Hello and welcome to Optimizing Runescape. Today we're going to be looking at woodcutting and trying to figure out the most mathematically efficient way to get from level 1 to level 99. Woodcutting is one of the most basic skills in the game, in which a player will use a particular type of axe to chop down one of the many trees in the game, and when they do so, they receive a pair of logs and some experience. The rate that the player gets the logs depends on the type of axe that they're using, the player's woodcutting level, and the type of tree that they're cutting down. In order to figure out exactly what that rate is, we're going to have to do some research. Okay, so after reading some articles and tweets, I think I have enough information to solve this problem. The important points are that every 2.4 seconds, you have a certain probability to get a log. For a fixed axe and tree, the rate that you get those logs depends linearly on your woodcutting level. That means that if we know the rate at any two woodcutting levels, we can interpolate the rate for any level. The only rates that have been released are two values for the teak trees being cut with a dragon axe. Thankfully, the speed improvements are known for each axe, and so by multiplying or dividing your way up or down the list, you can find the rate for that tree, but with any axe. It seems like the only way to figure out the rate for other trees is by estimating those values, but I'll come back to that after. But right now, let's see if we can code up what we have so far. Okay, so what I'm doing here is I'm just typing in all the values for the axes and the trees. For some reason, the wiki doesn't have the crystal axe multiplier, so I had to calculate that manually. Next, I'm writing the interpolate function, which will take in rates at two different woodcutting levels and will allow us to calculate the rate for any level. For those paying close attention, they might notice a little bug since the x and y values are swapped, but I'll fix that later. The next thing is to be able to convert a woodcutting rate from one type of axe into another, and the way that we can do this is by taking the axe that rate was calculated for and dividing the probability by it. This will essentially give us the probability of chopping a log with a bronze axe. Then we can just multiply by the axe we actually want to use, which would give us the desired rate. Finally, we can put this together, and to calculate the rate, all we have to do is to convert the woodcutting rates to the player's axe, interpolate to their level, and multiply or divide by the appropriate experience and time. Now that we set up that model, we can start to look at some of the results that this will predict. This graph shows you the experience per hour when cutting teak trees if you use the best axe available to you at any given woodcutting level. Cutting a teak tree requires 35 woodcutting, but because this is just a model, it lets us calculate those rates even before that. There are two interesting trends that happen. The first one is that about every 10 levels there'll be a jump in the woodcutting experience, and that's obviously because a better axe is unlocked. However, when the axe is fixed, we get that linear increase in the woodcutting rate that we put into our model. The next thing we can look at is fixing the woodcutting level, but then varying the axe that we use while cutting the teak tree. Here we see a relatively linear improvement in the woodcutting rate based on the different axes, although there are some variations. So all of these insights are pretty interesting, except that we're still limited to one type of tree. So in order to model those other trees, we're actually going to have to go into the game, cut some trees, and estimate those probabilities. So even though we already know the probabilities for teak trees, it's a good idea to check that my method for estimating the probabilities is going to agree with the teak trees first, and then we can move on to the other ones once we're confident that it's going to work. And it's actually really easy to estimate that probability from the number of logs that you can cut per second, since the probability is essentially the number of logs you cut in 2.4 seconds. So by just dividing by 2.4, we get that probability. My estimate based off cutting one set of trees is 0.56, and if we go to the code and run the parameters that I'm using, we get the prediction 0.59, which is really close, especially based on this small sample. So it looks like this is going to work, and we can go try out other trees. Okay, so this is me cutting normal logs and trying to estimate that probability, but because of how quickly normal logs get cut, I'm using a bronze axe, but even that's not enough. So what I did was I counted the number of logs that were cut in 2.4 seconds, in 4.8 seconds, and 7.2 seconds, because those are all multiples of that base interval, and I use that to generate the average. Oak logs are a lot easier because they're slow enough that you can just count the number of logs before the tree falls and measure that time to get that rate. It's still very slow, and I took a couple samples in order to get a better estimate. Where it starts to get tedious is at willow logs because it just starts to scale so much slower, and a full inventory would take about 7 minutes. The last tree I'm going to do is going to be maple trees because remember that we need 2 woodcutting level estimates for each tree in order to be able to do that interpolation. What that means is that I have to have 2 accounts with different woodcutting levels in order to estimate that. The woodcutting levels have to be very far apart, so me getting 1 or 2 levels wouldn't be enough. And so I only have one free-to-play account that has 45 woodcutting, and so that's what I'm going to have to use to estimate that second point. So I finished collecting all the woodcutting data. It was a bit more tedious than I wanted it to be, and I also had to complete the Corsair curse for my other account to be able to cut maples. But now we have 2 estimates for 4 different trees at low levels, and we can use this to try to extrapolate to higher level trees. Because we expect Jagex to use relatively simple equations, we can kind of make an assumption that there's an exponential decay happening, or maybe something like a reciprocal function. But either way, the probability of getting a log would be pretty similar. Overall, this means we're left with the exact value for teak trees. We have an estimate for low-level trees, normal, oak, willow, and maple, and we have extrapolations or predictions that let us estimate what it would be for higher-level trees like mahogany, yews, magic, and redwood trees. This effectively means that within the approximations that I had to make and the estimates that I had to make, that we can predict the woodcutting experience for any woodcutting level and for any tree, which is really powerful. And what it's going to allow us to do is it's going to let us kind of brute force at each level what tree gives the most experience. And so we can figure out what the ideal tree to cut is at each level for a character training woodcutting. So I went ahead and plotted the woodcutting experience per hour using the best axe for different trees and at different levels. Some of this doesn't make sense due to level requirements like I mentioned earlier, but it's still interesting to see. The red line represents the exact teak tree values, the blue lines are the estimated trees, and the green are the extrapolated ones. There are some odd features that suggest issues with the estimation. For example, the experience for normal logs below level 15 is actually clamped to 0. Also, either the maple tree is relatively constant or the high end is underestimating the chopping rate, and the magic tree experience seems a little bit high. That being said, the only way to improve this is to either ask a JMod for the values or to get more samples. Maybe a RuneLite plugin or the crowdsourcing that's happening on the wiki right now could help, and then just updating the numbers would resolve all of these issues. If we continue on, we can try to determine the optimal trees to cut. The way that I did this was that at each woodcutting level, I used the best axe and checked the experience rate of each tree. Whichever tree gave the fastest experience rate was the optimal tree for that level. What we end up with is normal trees from level 1 to 14, oaks from 15 to 36, teak from 37 to 69, and then mahogany onwards. Now, I don't think you should trust this just yet at this point, but with good enough estimates in the future, this could be really helpful. There were also several assumptions I had to make. Probably the most important was no banking. This simplifies things because it means we don't have to consider inventory space and, more importantly, bank distance for each different tree. But a lot of people obviously bank their logs. A way around doing this in detail could be to assume that the average distance to a bank, regardless of the tree, is about the same. Then you could factor in the rate that you get logs, and therefore the number of times that you have to bank every hour in order to correct the experience rate. There were also no boosts like the lumberjack outfit or the woodcutting guild and tick manipulation, which are often used. This is part of an open source project called Old School Runescape Math that you can find on GitHub. So if you think that you can help improve these models, or if any of this is interesting to you or you have any questions, I recommend you check it out. Thanks for watching.